Today we are going to talk about E or Z assignment. Before we talk about the Kahn-Ingold Prelog system assignment, it is important to understand why we use this system. Here we have two alkenes, which is an organic compound that contains at least one double bond. This double bond restricts the groups on either side from rotating, so this configuration will stay like this. These two alkenes are stereoisomers of each other, meaning that they have the same molecular formula and connectivity, but the groups have a different arrangement, so they have different properties, such as boiling point or melting point. Because of the different properties, it is important to know which compound we are viewing. We use cis and trans nomenclature as a way to do this. Describing a molecule as cis or trans usually works to determine the location of the groups, but that system is only really ideal for a molecule that has two identical groups. This alkene is cis-2-pentene because the hydrogen groups are on the same side here and here, and the carbon groups are on the same side here and here. This alkene is trans-2-pentene because the groups are on opposite sides of each other. Because of the identical groups, this system is efficient for determining the location of the groups and naming the molecule. For some of the more complex alkenes, this system does not work because of the ambiguity of the location of these groups. For example, these alkenes have 4 different connections, making it difficult to describe which alkene is cis and which is trans. For these alkenes, we have to use the Kahn-Ingold Prelog system. This system uses E and Z to describe the molecule. E and Z derive from German words, and E means opposite and Z means together. To be able to assign E or Z to a molecule, we have to prioritize the 4 connections to the carbons of the double bond. There are 3 important rules for prioritization that we are going to discuss in this video. The first rule is, the higher the atomic number of the atom directly bonded to each carbon of the double bond, the higher its priority. Here is a quick reference for the priority of some groups you are likely to encounter. As you can see, it is based on atomic number of the groups. So this group here has a higher atomic number and therefore has a higher priority than hydrogen or a methyl group. If the higher priority groups or substituents are on the same side of the double bond, the alkene is assigned Z. On this diagram, the H signifies the higher prioritized group and L signifies the lower prioritized group. If the higher priority substituents are on the opposite side of the double bond, the alkene is assigned E. Let's go over the example from earlier. The easiest way to go through this is to assign prioritization on each carbon first. Draw a line down the middle of this double bond here. This left carbon on this alkene has a Cl group and an F group. On the right carbon we have a methyl group and a hydrogen. Because CH3 has a higher atomic number than hydrogen, the methyl group has priority on this carbon. Because Cl has a higher atomic number than F, Cl has a priority on this carbon. Now, draw a line down the middle of this plane, through the double bond. The higher priority substituents are on opposite sides, so the alkene will be assigned E. Let's do the same process with this alkene here. Draw a line down the middle. Again, Cl has a higher atomic number than F, so it receives priority on this carbon. Same with the other carbon. The methyl group has a higher atomic number than hydrogen, so it has the priority on this carbon. Now, draw a line through the middle plane. The higher priority substituents are on the same side, so this alkene will be assigned Z. The second rule explains that if the atom bonded to the carbon of the double bond are the same, then we must look to the next atom over for a priority. Here is a guide to increasing priority. Again, it has to do with atomic number. Let's try an example. Remember to assign priority on the carbons in the double bond, not the alkene as a whole. Draw a line down the middle of the double bond here. Since we have a carbon attached to another carbon, we have to take a look at what is bonded to the carbons here. This carbon is attached to 3 hydrogens, and this carbon is attached to a methyl group. So this carbon here is prioritized. On the other side of the bond, this carbon is attached to a Cl and this carbon is attached to an OH, so that we know that this carbon here is prioritized. Now, draw a line through the middle of the alkene. The high priority groups are on opposite sides, so this alkene will be assigned E. Go ahead and try this example for yourself. Pause the video now. Hopefully, this is the answer you got. This group has a higher priority than this group, and this group has a higher priority than this group here. Therefore, this molecule will be assigned Z. The last prioritization rule of this video explains that atoms bonded to a double or triple bond are treated as if they were singly bonded to the same number of atoms. Here is a quick guide to show you what is meant by that. The prioritization is still based on atomic number, but now we have more atoms to account for. Here is an example of what this means. While this can be a bit tricky to understand at first, there is a process that will make it easier for yourself. Look at each carbon and write down what the 3 connections to that carbon are. This first carbon is connected to 3 hydrogens. This carbon here is connected to 3 more carbons, making this the prioritized group on this side of the double bond. This carbon here is connected to 2 oxygens and 1 hydrogen. This other carbon is connected to 3 nitrogens, making this the lesser prioritized carbon. Because our high priority groups are on the opposite sides of the alkene, this alkene is assigned with a Z. Go ahead and try this next example for yourself. Pause the video now. Hopefully you are able to determine that this alkene has an E assignment. I have color-coded the 4 identical carbon connections in red here, which means we had to look at the next atom over in these carbons. These next carbons are color-coded in green. This group does not have another carbon connection. It has 3 implied hydrogens, which are color-coded in blue because carbon makes 4 connections. We can determine this is the lower prioritized group and this group has the higher priority. This top group has only 2 carbon connections, whereas this group has 3. Therefore, we can see that this bottom group is prioritized higher than the top group. Because our highly prioritized groups are on opposite sides, we can say that this alkene will be assigned E. Thanks for watching my video. I hope this helped you understand the Cahn-Ingold pre-log system better.